Right, good afternoon everyone. I'm Sean. I'm going to be talking to you about building applications with Qt 3D. I'm very much aware the party follows this, so I will definitely try to finish on time. I do not want to stand in between anybody and their beers. We'll see how we get on. We're running a little bit late, so let's get cracking. So what is Qt 3D? Well, at the basic level, Qt 3D is a soft, real-time simulation framework. Now, as part of that, obviously people want to draw things, so included in Qt 3D is a very nice little data-driven renderer. Now, what do I mean by data-driven? Well, usually when you write a 3D renderer, the actual rendering technique that you want to use gets hardwired into C++, or whatever language you're using to write your application. Now, with Qt 3D, we wanted it to be flexible and also to be able to be used to experiment with new rendering techniques as they get researched. So with Qt 3D, the actual renderer config is entirely defined by data in your QML application or by data in your C++ application. So unlike with the Qt Quick Scene Graph, where it's hardwired to, for example, render all of the opaque objects, followed by the transparent objects sorted from back to front. That's one thing you can do with Qt 3D's renderer, but many, many other possibilities are available to you. And you can get anything from a simple forward renderer to full-blown deferred rendering and everything in between. We also want to be able to handle inputs of all different kinds. So we're going to start off simple with the traditional mouse and keyboard, and then we'll eventually add in more esoteric input devices like 3D mice or the Oculus Rift controllers as we go along. And very importantly, Qt 3D has been designed from the ground up to hopefully be extensible. So as people have new needs, so for example, if somebody wants to add in collision detection to their system, we'll be able to write a module for that in the future. Likewise for physics or 3D positional audio or any one of a number of other things that you may be able to think of. And it will be extensible by you guys as well, not just by us. So what sort of things can we use Qt 3D for? Well, primarily we want it to make it easy to add 3D content into your Qt applications. Now what those applications are, of course, is up to you guys. There's a picture here of a demo we have running on the KDAB booth at the moment, showing a little jet engine. On our booth, that's running on a little embedded Tegra board from NVIDIA. But it also runs on all the usual desktop platforms, and it could run on a whole host of other embedded platforms and mobile devices and tablets. Qt 3D allows you the flexibility to target your application across all these different range of devices. There may be some little tweaks you need to make in terms of the specifics for the shaders that you want to run if you're writing your own custom shaders, but that's relatively minor. We can also mix Qt 3D with widgets and, of course, with Qt Quick 2. So here on this example, you can see the panels in the corners. They are actually Qt Quick 2 controls, and we can overlay and underlay them and mix them in with the Qt 3D content. Hopefully, we will be able to provide you a nice set of components to use out of the box that meet most of your use cases. But those of you that really want to push things along, will be able to also customize and extend it with your own object types. So things like new materials, perhaps ones using physics-based rendering, or any other specialized rendering methods that you happen to need. And as I said, because it's data-driven for the renderer, we can configure new rendering techniques and try them out. Very nice way to do rapid prototyping and also academic research. Yep, and the usual fields of scientific engineering, games, data visualization. So for this session, we are going to show some basics of Qt 3D by basically making a very simple start to a space shooter type game. Just because I'm doing an example about a game doesn't mean Qt 3D is only for games. The same techniques apply no matter what type of 3D content you want to put into your application. I just chose a game because it's easy to relate to. So we're going to have a stab at doing this semi-live. I have coded the application, but we're going to build it up in easy-to-digest stages. So the first thing we need to do is create the basic application structure. And in this example, we are going to use QML because it's just so much more concise than doing it in C++. But if you want to do this in C++, you can, of course, pick that up and use the C++ APIs for Qt3D there too. Now, the first thing we're going to need that's a little bit new is something called the QML aspect engine. Now, Qt3D is broken down so that each of its slices of functionality are split out into a separate submodule of Qt3D. So we call these things aspects, and the bit that ties and manages all these things together is called the QML aspect engine, if you're using QML. There's also a Q aspect engine if you're using plain C++. It also combines in our good old friend, the QML engine, so we've got all the nice things like property bindings and updates and animations as well. We also need a window surface on which to draw, so we're going to subclass a very simple subclass of QWindow, where we can just set the OpenGL version we want to use, and our window also acts as the event source for the input events that we want to pump into Qt3D. And very importantly, we're going to need the render aspect because, hey, we want to draw stuff, and the input aspect so we can handle keyboard input in this example. So let's have a look at step 1. It's pretty straightforward. I should have this one already loaded, I hope. Oh, need a little bit bigger font. Oh, hang on. Oh, no. Bear with me a second. My screen has gone a little bit funny. I'm seeing something different to you. Right, there we go. That's Creator. So, bigger font. Is that readable at the back? Yep, thank you. Right, so we have, in our main function, a QGUI application. We're not using widgets in this case, so we don't need the full Q application. And then we have this guy, window, which is a subclass of QWindow. So if we go in and have a look at this, very, very simple. All we're doing is in the constructor, we set the surface type to be OpenGL surface, because Qt3D is based on top of OpenGL. And then we create a QSurface format, and we ask for OpenGL version 4.3. Now, on this particular laptop, it won't get version 4.3, but hopefully it will return me 4.1, which is the maximum that Apple supports at the moment. We're also going to be using the core profile. We've designed Qt3D to work primarily with the core profile and the new feature set rather than the legacy stuff in OpenGL. It should also work with the compatibility profile if you want to integrate it with some legacy code as well. Then we've got some little bits and pieces here, setting up some options that are needed by Qt3D and Qt-Quick, and then we set that format on the window, and we create the window explicitly. Behind the scenes, Qt3D will use that surface format to create its OpenGL context, ready to do its own rendering. But we're not going to dive into that today. So we have our window, and we resize it to a reasonable size. We then have our friend QML aspect engine, and to that engine we add two pieces of functionality. We add in our QRender aspect and our QInput aspect. The renderer draws things, input deals with input events. Now, if you wanted to add in collision detection, you could register an aspect that knows all about collision detection. If you wanted one that does a physics engine on top of Havok, you could write your own Havok physics aspect, or one on top of Bullet, or any other engine that you want to use. Perhaps you have an in-house one. It's up to you to register which bits of functionality you want. We're then just exposing an object to QML, and then here we create this QVariant map where we set some configuration data for Qt3D, which basically says which surface should I be drawing on for the renderer, and for the event source, it tells the input aspect where it should get its inputs event from. And then finally down here, we're just loading up a main QML file, which we can have a quick look at. It's pretty simple. So we import some QML modules at the top. I've accidentally imported Qt-Quick 2.1 as well. I'm not sure I need that just yet, but never mind. So at the root, we have this thing called entity. Now, an entity is basically an empty container. It has no particular behavior on its own. It's pretty much analogous to item from the Qt Quick 2 world. To make it do something useful, we have to give it something called a component. And we're going to see a bit more about components shortly, but for now, we give it a default frame graph. This is a piece of data that controls how our scene is rendered. So we're using the built-in forward renderer, which basically says, just draw everything straight to the screen. We're not doing any deferred rendering or rendering to textures or anything other fancy like that. We have a keyboard controller, which is basically going to feed our keyboard events into our application in a little while when we hook it up. And then inside here we have another entity, which is going to act as the root for our 3D scene content, and then we have a camera. So our camera has all sorts of options on it. We can have perspective projections or orthographic ones. In this case, we're going to use orthographic. And what we're doing is we're setting up a game area where, if you imagine this table is our play area, we have a camera above it, and we're looking down onto the game area. Now, if I build and run this, we're going to see something very boring. There we go. Hurrah, we have a black window. Yep, that's quite normal for OpenGL, by the way. Staring at a black window is a very common pastime for OpenGL developers. So the key is, how do we make these pixels not black? Well, one thing we can do with the frame graph that's built in, this forward renderer, is we can set the clear color. It's a property that gets exported, says what color to clear the screen to, so we could just change that to white, and then we'd, hooray, have a white screen instead. But that's not very exciting either, so we won't bother doing that. Where are we? There we go. So the next step is to understand a little bit about entities and components. So Qt3D fundamentally is an entity component system. You can go Google this if you like. It's a whole field that I hadn't come across before a couple of years ago, but there's lots and lots of papers on it. Quite popular these days because it allows reusing different pieces of functionality in ways that you can't imagine as a library developer up front. The idea is to keep Qt3D as flexible as possible, but still provide good performance. So we add components onto our entities that provide little bits of behavior. So for example, if we add on a transform and a mesh to an entity, we will have something that gets rendered by the renderer. If we were to add something like a bounding volume, then that might be picked up by a collision aspect and be able to be used for collision detection. So entities just aggregate components. And the aspects, the renderer, the input aspect, whatever else, processes the entities fed into our Qt3D world depending upon what components they have attached. So to display a mesh, we need a mesh component, which is able to load data from Wavefront OBJ files. It's a very simple file format we can parse in, and Qt3D will then render that data for us. We also need a transform component, which allows us to tell Qt3D where to render our objects and in what orientation and in what size. And finally, we need some form of material component which says what that object should actually look like. Now, there is a default material if you don't specify one, and it's very ugly, as we will see in the next step. Deliberately so. Right, let me... Okay, so let's go back to Creator. Oh, this thing keeps switching out of mirror mode when I go back to the presentation. Let me just leave this window open. There we go, back to Creator. So I just need to get my notepad and get the second step. And now Creator doesn't update either. I'm not having a good day today. Let me close the project and reopen it. Okay, so now in our main QML, we? We have our camera down there. We now have a new thing here called player ship. Now, a player ship is simply an entity, and because we're in QML, we can give it a whole bunch of properties, and we're giving it things like health and its starting maximum health, the score, and what the base name of the mesh is we should be loading. I've set up all the assets already to use in resource files, so we don't need to worry about doing that. And then we've got some other bits and pieces like position and scale and roll and pitch, etc., that we want to be able to use. Right, so let me see what else we've got down here. So below this, we have a little function called onHealthChange. We'll get back to that later. That's just a little hack until we get a full game working. We have this common little pattern here where you make a D object, analogous to the sort of D pointer objects in C++, that can't be accessed from outside our top-level entity. And inside here, we're just building up where our asset is. And then down here, we have the components property. And for the components, we set up our mesh and a transform. So our mesh is very, very easy. We just specify the source property to point to our OBJ file. Easy. And for the transform, we can build this up from sub-transforms however we like. That's entirely up to our particular use case. Yeah, that's all we need. And then some of those are just exposed as properties up here or have bindings to them. Now then, why is that not updated? Bear with me 1 second. Something seems to be missing. Wrong one. So just let me copy that. And paste that in. And then let's chop that stuff out because we haven't done that bit yet. So we have a player ship that we can instantiate. It's just a custom QML component. And we give it a name. It's got a direction which says which way it's facing in our game area, a scale, and a position. So let's just build that quickly and run. And hooray, we now have a very, very ugly brown spaceship. Right. The default material is deliberately very ugly to encourage you to go and change it to something that suits your needs. Now, if you really like brown spaceships, you're free to stick with it. Personally, we're not so keen. So how can we change our appearance? Well, we can use different materials. Yep, we have built-in materials that handle the usual kind of lighting, so diffuse and Phong type lighting, and they can also take in data from textures as well. So we can feed in diffuse and specular and normal map textures and do a whole bunch of other things. There's no way we can cover every possible use case because they're as wide-ranging as there are many people in this room. Of course, it's very easy to add your own, but let's just get somewhere else. Let me just reset minus hard so I don't mess that up. And get the next stage. So now in our player ship, we should have sorry, something is going very strange here. It appears my objects are not updating. Okay, I'll show you on the complete example anyway, to save a bit of time. So on our complete example, we have now inside of our player ship QML this guy here called diffuse specular map material. Now what this does is a Phong lighting model. So it's got ambient, diffuse, and specular contributions, and we're getting some of the data now from textures, also inside of our assets, which are just standard JPEGs. We're just going to interpret them in a slightly special way inside of the shaders. Bear with me 1 second, something's gone very strange here. Is it just because Creator's not updated it? close project, file, open recent projects, space shooter, demo, into QML. Nope, something's gone wrong with my Git repo. Oh, that's annoying. Sorry. Right, so we have this material where we can specify the different custom appearance. Now, it's going to be a little bit annoying if I can't show the individual steps. Let me just see if I can get the next one in the hope that something picks up and goes right. Control C and Control V, git check out that. Build and run. Okay, so I've covered two steps here at once. For some reason, my creator's not showing me these files as I think they should be. So now we have our ship, which is using a different material, and it's got a nice texture on it to give our ship a spaceship-y type appearance. And when we get to be able to move it around, we'll be able to see the lighting effects working on it. Now, I've skipped to the next step accidentally by mistake, so we'll just talk about that very quickly now. You can see we have this scrolling background. Now, that background is very, very simple. Remember, we have our camera up here above our game area, and this table is now just a single flat rectangle, and all we're doing is we're putting a single texture image onto that, and then using a bit of magic to make the texture scroll repeatedly. So we're just changing the texture coordinates a little bit each and every frame. Now, the way we change the texture coordinates is by using something called a logic component. So if I just switch back to the presentation, I think there's a slide here somewhere. So we're using a plane mesh, which gives us a flat rectangle, and a texture material, which just applies a texture with no lighting whatsoever. We want to animate the scrolling. We use a QLogic aspect. So to make this work, we need some extra bits in our C++. We have to register the logic aspect into Qt3D, and then we use a logic component in our application. So in C++, in our main function, what is going on? This is just not showing me at all what is on my hard drive. Let's have a look. Right, so let's close Space Shooter demo, and let's explicitly file, open file or project, development, Space Shooter demo, go. Nope, something's gone very, very weird there. I don't know. I'll show you in the final solution. Let's forget that one. Let's forget the individual steps. Right, so in our main function, of course that's different in there. We do it slightly differently in the full version where we've got Qt Quick in there as well. But basically we just register the aspect, and then inside of our background, so we have our, what would be our main, we now have a background object here. And again, we set its position and its height and its width example, and we can give it a speed. Now inside a background, oh, sorry. This presentation thing, every time I switch to the presentation, it's changing the mirror mode of my display. I do apologize. This is very, very bad. Right. So we now have this background element we are creating. So we give it a position and a size that matches the aspect ratio of the image we are feeding in, and we give it a speed at which it should animate. Now, to make it animate is pretty easy. We just have an entity. It has a transform and a plane mesh, which sets up the appearance of it, and the texture material uses the correct shaders to load up that texture and apply it. And then inside of this material, we have this property called texture offset, which we just apply to this vector 2D with 0 in the x direction, and vertical offset is something we're going to calculate once per frame. To calculate something that gets executed once per frame in sync with Qt3D, we can use this little guy called logic component, and once every frame, we have this on-frame update function that gets called, and we can do calculations in there to make things animate nicely. So inside here, we're simply updating material vertical offset a little bit to make our background appear to scroll behind us. There's no geometry moving. All we're doing is updating the texture coordinates. So our application is still pretty simple, if I could actually manage to work my computer, that is. What can we do now? Right, we have done all that. We can also use a simple property binding to add parallax scrolling when our ship is able to move, which is what we're now going to add in the next step. So we use the keyboard input component to allow our entities to start receiving keyboard input. We then use the logic component to take that updated state from our keyboard input events, and we're going to translate that into axis control values that we can then use to move our ship. Now, the logic component we've prototyped here will likely be updated or upstreamed into Qt3D as part of the actual Qt3D input aspect. So this is just a temporary workaround for now. So to have a look at the player ship, what we have here in the player ship is a new component, which is right down the bottom, and it's called Input Manager. Oh, this thing. I thought Apple's were supposed to be easy to use. It's Microsoft PowerPoint, that's the problem. Screwing it up. Seen as a virus on it or something. Right, so we have this Input Manager. Now inside here, again, it's just another entity, but it's one that's going to behave differently. It has no visual representation. All we want to do is handle input events, so we have a keyboard input component, which we again assign to our components property. And inside here, we have the on-pressed and on-released signal handlers, completely analogous to Qt Quick. And inside here, we're just going to track some state about whether we're moving horizontally or vertically. And we can also do it for a mouse input if we like as well. And down the bottom, we have another logic component, which does a little bit of calculation about working out how fast we're moving based on the acceleration properties we give to our little ship. So it doesn't just move linearly, it actually accelerates and decelerates nicely. Now, for our player ship, we have the input manager, and we also have this extra little logic component here that uses the input manager and its horizontal axis property to say how much should I move this time step since the last frame. Same for the vertical. And all we're going to do is update the X and Z properties of our ship based upon that. Now when we run that, if I just get the next step, I can't show you the code from it, but it seems to run it. Get checkout that. And then build and run. So now we have our little ship, and when I use the arrow keys, we can now move our ship around, and with the little property binding to set our parallax scrolling, we can move our ship around and the background moves in the opposite direction. Now to get that parallax effect is very, very simple, and you can see on the ship we have the lighting effects as he moves, and it reflects the light, which is at the same position as the little camera. So to make that parallax effect, all we do is we set the X property of our background to be some fraction of our player ship's X position like that. Very, very easy. Right, so the next step is we need something to shoot at. So we're going to spawn some bad guys. Now we make another entity, which again will have no visual representation, it's just going to make baddies for us. So we're going to use some dynamic QML instantiation. Again, we're going to use one of these logic components to decide when to do that, and do some maths about generating random baddies. So let me just get the next step. I'll change it back to the present creator in a second. Remembered this time. So now if we just build and run it, and then I'll show you the code to do it. So now we get asteroids falling down, and they're rotating, and we get some little ships come down. Just a bit boring at the moment, but the asteroids are coming down and they're spinning at random orientations, and they're being generated at random positions across the screen, and we could then move around and try to shoot them, if we were able to fire anything yet. Right, so let me go back into here, and what we now have is one extra object, which we've called Game Controller, and inside the Game Controller, we have, surprise, surprise, an entity, so it's just like item, we use it all over the place. It has one component called the spawner logic, and we then implement the component.onCompleted signal handler from QML, and inside here we create a couple of factory objects. So we are creating a factory object for our asteroids.qml and one for enemy ship.qml. Now these guys themselves, again, are just entities with different meshes and without the input components that our player ship has, because they're controlled by the computer, not us. This chunk of code here is just a little trick to force Qt3D to preload all the different models for the asteroid types that we have. We do this once up front to stop the game lagging a little bit when it actually starts up and the first time it creates an asteroid. So that's entirely optional. And then the spawner logic basically just says on-frame update, and then every n frames, so when we've got 360 frames or up to some multiple of 120 frames, we're going to create a baddie of one sort or another. And we're doing that just by using the old create object from QML and setting properties on the object, calculating things like a random X position and a random rotation for it. So really quite simple. All right. Oh, and yeah, one thing I forgot to mention. Right, back to here. Turn that display off, stupid thing. Is when we create our asteroids, for example, again, it's just an entity with a mesh and a material, and it has a logic component for updating its position. We have this extra little logic component down here called destroy on leave magic. Destroy on leave logic, not magic. It is magic. All we do is we basically check each frame to see if it's left our game area plus some little margin, and if it has, we destroy the object that was dynamically created. So very, very simple, but it means we're not keeping track of all the objects that have flown off the bottom of the screen that we didn't manage to shoot. So we just keep a reasonable number of objects around. Right, so now we want to create some bullets. Now this is basically the same idea as creating the enemy ships and the asteroids. In this case, we're going to create them dynamically when the user presses the spacebar to fire the little bullets, and we need to get them to animate themselves and destroy when they're leaving the game area so we can reuse some of the logic we've already created. Right. Let me see if I can fire that one up. We're nearly there. And turn the display off. And then if I build and run, we get some baddies coming down. We can't actually shoot them yet because we don't have collision detection in just yet. Now if I shoot, you probably can't see it very well because the bullet's going too fast. But each bullet is just a little rectangle with a picture of a laser bolt on it. But there's a problem. If you see as it's going up the screen, we see all the black border around it as well. Now that's not very good. Yep, we want something that looks more like an actual laser bolt rather than just a square with a colored stripe up the middle. So we need to do a little bit more effort. Now what we do is we need to make something that changes the way Qt3D is drawing our scene. For our bullets, we want to use no lighting. We're just going to use a simple rectangle with a texture on them. But we need blending. We want to be able to see through that rectangle where the laser bolt is not bright. So to do that, we need to turn on blending, and to do that, we need to customize the frame graph that we're using. We can't just use the simple forward renderer anymore. The frame graph determines how the renderer processes the scene. So we have a little example here. The scene graph is what to render, and the frame graph is how to render it. And we can build up a little tree of frame graph nodes using nodes like this. So we can have a camera selector which says which camera are we rendering that part of the frame from, what technique should we be using, and should the data be sorted before we submit it to OpenGL, and lots of other options as well. Now we process our graph of frame graph nodes in a depth-first order, and for every leaf node, we basically submit a job that creates all the draw calls for that bit of the frame. So here we see an example where we have a frame graph that draws one scene from the point of view of 4 different cameras. Now to do that in Qt3D1 would have basically been impossible, I think. But now it's a very, very simple case of you still have the same scene, we just change the frame graph that says how it is rendered. So we have 4 cameras, and we render each camera into each quad of the screen. So the way that works is our frame graph looks like that graph on the left, and for the first set of render commands we build up, we simply clear the buffer for the viewport represented at the top level of our tree. Now on the second thread, we will build up a set of render commands that processes that leaf node with camera selector 1 at the bottom. So we'll basically see which objects we need to build and render from that camera's point of view. And then there'll be other threads and other jobs that build them up from the other leaf nodes of that graph. When we process them all and submit them to OpenGL, we end up with the image on the previous slide. And these things are all happening in parallel on the back end. So Qt3D scales up across as many threads or as many cores as you care to throw at it. And your own aspects can take advantage of that job framework on the back end as well. So let's have a quick look at how we do that. Just let me get the next bit. To there. And I need to turn the projector back on. And then we go into here, build, and run. And now when I fire the bullets, we literally just see the bullets going up. Yep, we don't see that horrible black rectangle around them. So we're able to change how we render the scene. Now to see what our frame graph looks like, if we go in here somewhere, we have a layered frame graph. Now, don't worry if you don't understand all of this. This is one of the more advanced bits of Qt3D. So we build our own frame graph. So at the top, we have a viewport, which covers the whole screen, yep, from 0 to 1 in normalized coordinates. We then say which camera we want to render from. We want to clear the buffers, and the final option on that first branch of the frame graph is we render everything that's tagged with a layer called opaque. So this is things like our ship, our background, our asteroids, and the baddies. We then render a different layer filter called blended. Now, it's our laser bolts that are tagged with the layer called blended, and as part of that, we also have this state set where we can set some advanced OpenGL options. So, for example, we can enable backface culling and set the depth test function, the depth mask. We don't want to write to the depth buffer while we're drawing the laser bolts, and we can set the blend state and the blend equation. So you can tweak right down at the OpenGL level, all from QML. But you only need to do this if you have the need to do it. You're not forced to do this out of the box, so don't worry if that looks scary. So we're getting there. Now we can add a 2D user interface over the top, and it's a 3-step process. The first step is we basically change our application. Instead of using a window, we use a QQuick view or a QQML application. The choice is yours. We then wrap our Qt3D content in a special little guy called Scene3D. Now, Scene3D is a custom QQuick2 item that is provided by Qt3D. And what it does is it acts as an intermediary or a bridge between the two worlds. So when we wrap our 3D content in a Scene3D item, the renderer then takes care of rendering our 3D world into a texture, and that texture is then rendered onto a quad in Qt Quick 2. So it works in a very similar way to the Qt Quick frame buffer object, but instead of using your own renderer, we feed in the Qt 3D renderer. And the third step is simple, just make money. So that's literally all there is to do to mix between Qt 3D and Qt Quick. Right, let's have a look at that. So I can just show you the final version now. So inside of our main file now, we have a GUI application, we have a Qt Quick view. Thank you. I will punish myself later. So in our main function now, we have a Qt Quick view, and this is just our standard Qt Quick view that we all know and love. We load up a main QML file. We're setting a window size. I've just made it a bit smaller so it fits on my low-resolution display. I obviously need a new computer. And then we show it. So our main QML file now is just our standard Qt Quick 2 stuff. So we have our root item, and then here we have our special Scene3D object. And we're telling it to fill the parent, so it's going to take up the full extent of our window. We're setting the focus to true so it receives the input events, and we have a property here called aspects. So instead of using register aspect inside of our C++ code like we had with a pure Qt 3D application, we can specify that here for the Scene3D object. So it's going to upload or register the input aspect and the logic aspect, and it always registers the renderer aspect by default because otherwise why would you be doing this? We then have a world 3D as a child, which is now what we've just renamed our old main QML to be. So this is our entity with the frame graph and our keyboard controller and our game controller for making the baddies and a camera, the background, the player ship, etc. And the rest of our QML file is just usual Qt Quick 2 content. So we've got some text that does various things and a health bar. And we've just had property bindings for our health bar, for example. We just bind that to the health property of our player object inside of our 3D world object. And then we have a simple little fade to black thing for the intro. And if I fire this one up for the full version, we can see this in all its glory. So we get a nice little KDAB logo. That then fades out, and we get our little space shooter game. We have some simple QML animations for doing the text, make that pulse. Because we don't have collision detection in just yet, when I start the game, we get the baddies come down. We'll get some asteroids and some baddie spaceships. Our health goes down automatically, even without them shooting us. The baddies now fire little laser bolts as well, and then they do a little roll off into the distance as they come down the screen. So this is all just a very simple extension of what we've seen today. When we get to the end, our health is out and it's game over. So if we add collision detection in, and hey presto, you've got a nice little shoot 'em up game. So hopefully that's given you a taste of how we make things with Qt 3D. It's basically entities and components. Just add components to your entities until they do the right sort of thing, and then you can do extra little bits of work in the logic component. You can integrate this with C++, and we've exposed quite a bit of the OpenGL feature set to QML. You can even do things like instanced rendering now, all within QML with your data coming from a backing QAbstract item model. So you can render thousands and thousands of objects very efficiently using Qt 3D. Right, thank you. Any questions? I apologize for the laptop issues. Yes, on what you're trying to do. So, sorry, the question is, what would be more efficient, using Qt 3D or Canvas 3D? And it depends entirely upon what you're trying to do. So if you're trying to port something from a Three.js example that you found, it would be much more efficient to port that to Canvas 3D. Canvas 3D is as said in the previous talk, basically a wrapper around OpenGL ES2, which is used equivalently to WebGL. Now, if you need more features than what that provides, then you'll be better off moving towards Qt3D or doing something explicitly on your own. Qt3D also has the advantage in that it scales up across multiple CPU cores, whereas the Canvas 3D is still limited to one thread. Yep. So it depends on your particular use case and whether you're talking about runtime efficiency or developer maintenance efficiency or porting efficiency. Okay? Yes?
Are there any restrictions to rendering techniques like...
Okay, so the question is, can you implement your own graphics algorithms, or are you limited to doing simple layer-based rendering like we saw here today? And the answer is you are not limited. You can use frame buffer objects. We have objects that wrap those, so you can attach your own textures, including multiple texture attachments at any time. You can implement completely deferred renderers using the frame graph. So it's up to you entirely what rendering technique you use. You should even, in theory, be able to do things like order-independent transparency, which requires some pretty advanced features. Does that answer your question? Yep. Anybody else? Yes. You may have to speak up.
Yeah, okay. Do you support other kinds of assets apart from OBJ?
Yes. So do we support other kinds of assets apart from OBJ? Yes. The mesh object at the moment just reads in OBJ files. We can extend it to other types of object or types of file later. But there's also another object called Scene. Sorry? Scene Loader. I forget the names. Which is able to load in anything supported by the ASIMP library. So that includes all kinds of different formats. We also support the Scene Loader is able to load in GLTF files. So GLTF is a nice binary interchange format specified by Khronos, which is due for release in the near future. But we already support it here. And if you go to Laszlo's talk, the Lightning talk later on, he'll show you how you can take assets and create GLTF files from them, which Qt3D can then load up very efficiently and quickly. And that's a compile time step. So it's all integrated into the build process, which is nice. Yep, go on then, have another one.
That's all the time we have.
Oh, okay, sorry. Catch me afterwards.
But Dr. Hammer is here, so you can find him at the conference. And could we have a round of applause for him?